So we have a question sketch, or rather the sketch below shows the graph of f of x that and g of x that. A and B are the x-intercepts of f. So we then know that A here and B, they belong to this. Now they say the graphs of f and g intersect at C, somewhere there. They intersect somewhere there, and B somewhere there. So what happens is D is the turning point of this function here, and then we have the questions. Determine the coordinates of C. Now for C, remember they intersect there. So C is where now your y begins. It's very easy. So this is your constant, which is the y value. Now what I'm going to do is I'm going to write down, just to show you how to solve this very quickly and easily. So say for example you make your x 0. So basically this is your y value, and for your y-intercept you generally would make what? X equals to 0. So we answer 5.1.1 by saying, okay, y is equals to, quickly bracket, squared minus 2, oh sorry, we said not, my bad, getting carried away. Okay, so we have that naught, we have minus 3, therefore y is equals to negative 3. Similarly for the other graph, the linear function, also you would get negative 3, because if x is not, then y is equals to negative 3. So once you have done this, you are moving right along. We will go right ahead and do 5.1.2. 5.1.2, calculate the length of AB. Now we're calculating from here to there. Clearly we know the coordinates of A and B because we are given a function and we were told that A and B are the x-intercepts of F. So that is easy. For the x-intercepts, what do? You say, okay, for my x-intercepts, now y will be equals to 0. And now we have your y equals to 0 equals to the equation. There it is. The equation is x squared minus 2x. Okay, minus 2x minus 3, right? And does it factorize? If it didn't factorize, we could have used the quadratic function. There are so many ways of solving or finding for x, but for now, luckily it factorizes. We therefore have our naught and our brackets to factorize the following, where we have our x and x negative 3. Clearly the 2 is negative, therefore the bigger number should be negative, and plus 1. 1 times 3 is what? 1 multiplied by 3 is what? Is 3. So the multiples of 3 that give you this number right here are 3 and 1 respectively. So your answer here will be x is equals to 3, as well as your x, or your x is equals to negative 1. So once you have this, you are gonna look, remember you are just looking for a distance between this point and this point, and these 2 points are a very good distance indicator, because clearly this is 3, x is positive here, it's 3, clearly there x is negative, it's 1. So what is the distance? So AB AB, according to what we have, will be your 3, which is positive. Let's say minus in brackets -1. So you put that into there. So your distance is 4 units, right? 4 units. That's how long it takes to travel from A to B. 4 units. So right now we have done that. So we'll move on to the next question, which is 5.1.3. Let's do this on a separate page. The question is determine the coordinates of D. Now, very easy. Again, coordinates of D. Where is your D? Your D is basically, let me just go with the black ink this time. Your D is there. Your D is here. Sorry about that. But your D is there, right? So that's your D. It means it's a turning point. And for the turning point, we know how we calculate the turning point. Hopefully everybody knows that for a parabola, you do an axis of symmetry, right? Yeah, for a type of parabola. These types are not the same. For this type, we can do an axis of symmetry. Let's quickly go ahead and start the question, which is 5.1.3. 5.1.3. Now for 5.1.3, determine the coordinates of D. We start with your X. So we will have an X and a Y, clearly, for the coordinates. So X, axis of symmetry, is equals to -B 2A, right? So that's the formula, and then we go and check our A is equals to 1, our B is equals to -2, our C is equals to -3, and we carry right along and say, okay, now that we have all that information, we are going to say, okay, B negative. So we have our B is -2 over 2 times something, which is our A, which is 1. And now we know that our axis of symmetry will be 1, because negative divided by negative is positive. 2 divided by 2 is 1. So that's what we have. So after this, you know you have your X part of the coordinates. Now you need your Y. For your Y, you will need to then substitute the 1 back into the function. The function is now X squared. It will be 1 squared minus 2, 1 minus 3. Therefore, once you have done this, you will note that this will be your 1, this will be your -2, this will be your -3, and your answer will be -4. And your coordinates for D are 1 and -4. So that's your answer. That's a full answer. So you should look at how many minutes you've actually spent on the question. You don't need to spend more time than you should on these questions. So you have now question 5.1.4, which says calculate the average gradient of F between C and D. Between C and D, right? So now you are calculating the average gradient. So to calculate the average gradient, you should always note that there is a formula for calculating gradient, and your formula normally is your y2 minus y1 over x2 minus x1. So we don't have enough space on this page. I'll move on to the next page.